We're talking about bash scripting, shell scripting this week, and one of the power of having a shell allows me to actually do command substitutions. I can do multiple commands on one line. I can use variables. It has a lot of power in how I'm able to work with the system. So, common my common logic would be if I use this, because I use this shell to execute some program. For instance, if I type in the command ls, my common logic is that my shell is just executing this command that I typed in. It doesn't really tell me that it's doing anything different than just executing the command. Um, and so summarily, when I type in ls-al, for instance, and I'm listing all the files, including the hidden files. Okay, these are the ones with the dot in front. They're normally hidden from output. It tells me that, yeah, what my logic would tell me is that my shell would execute the ls command, and the ls command would then look at the rest of my input. And so if all I ever did was utilize this command and put some parameters or switches at the end, that's kind of what I would think would happen. But that's not really what happens. The shell actually interprets the commands that are given before it does anything. So here's an example. There are special characters in the command, and one of the special characters is a $sign. So I get to use that $sign, and I can do a lot of different things with it. One of the things that I can do is I can do inline substitution, and that also falls into command substitutions and variables. So normally when I use this command line, I can stack the commands. So I'm going to go ahead and clear my screen here, and I can, if I do echo 1, I'm going to echo whatever I told it to echo. And if I actually put a semicolon, my interpreter is going to see that semicolon, and it's going to stop that command and execute it, and then it's going to execute the next one. All right, so both of those commands get executed. What I will get is 1 and then 2. Notice there's a new line between each one. That indicates that my shell interpreter executed that first command fully, and then it executed the second command after that. Now, I could actually use the /n to suppress the new line, and notice that it did exactly what I told it to do. It did not interpret that space right there as a space. That semicolon became the end of the command. Now, convention would tell me that if I went back and I put the space in, that it would also include the space, but it does not. It does not include that trailing space. If I want that trailing space, I have to use some tick marks to get it. But I can take this command, and here's another example. If I wanted to echo, this is the list, and then I want to end that command and do a new one. Here's my list of files with "this is the list" prefaced beside it. Now I could also utilize, instead of utilizing the semicolon to stack 2 commands, I will make it all one command. So I'm going to echo, this is the list, and I'm going to use my ls command, but I'm going to evaluate it immediately. Notice that it did it a little bit differently. I'm not evaluating that it's two commands now. Instead, what I'm doing is I'm taking the output of the ls command and I'm printing it just like anything else. So there's a difference here. In my what I see is the output of the ls command itself. Notice that my shell colors the folders and everything. But in this case, it doesn't, because it is actually just printing the output as if I had just typed it in the keyboard. Okay. Okay. So what I could do also, I could substitute any command using that $sign. All right. If I wanted to have a command execute, anything I type inside those parentheses is going to be executed, and the output will end up being replaced. This can actually come in handy if I want to send a stream of data into a program in a certain way, and I wanted to execute that data with particular parameters. It's just going to replace whatever I typed with that $sign and the parentheses. Okay. Now what I can also do is I can use my shell to hold variables. So if I wanted to assign some text to the variable g, right, I could use g and an equal sign and type in the word text. Now, if I wanted to use echo and the $sign g, that $sign g is going to be replaced by the variable g. And so that is the same as if I had typed in echo text. Right? Notice that if I put a space right there, the shell tries to interpret that following the space as a command. So if I wanted to use an actual string and include some spaces, I got to use the tick marks. Now I can echo $G, and I get the contents of G. This could come in handy because I can assign portions of commands into variables. Now remember, we talked about substitution. So substitution also follows if I made H the ls command and I the $ls command, we'll show you the difference. If I echo H, I'm going to get ls. If I echo I, and I have to use a $sign to substitute whatever that parameter is right there with the value that's in I. Notice that what happens is that when it substitutes, it actually evaluates that command. But it places the text in its place. Now, if I did I right there, what it tried to do was execute the first command, desktop. Right? It interpreted this as that I had actually typed in desktop at the command prompt. So it's very literal, and know that when I use the $, I'm actually replacing what I typed with whatever's there. So that's why echo $I and $I are two different responses. One is I'm actually replacing the $I with the evaluation of the ls command as if I had typed it at the command prompt. Okay. It doesn't know what to do with desktop. It's not a command that it recognizes. Now, I could easily make a file and it had the same name as a command and echo that on this command. It would actually try to interpret that command as something that was typed in. It would work. But so we can use variables to hold. Not only can we use them to hold values, as in H up here, right? It's an actual string. So if I did echo $H, what do I get? LS. But if I do echo $G, echo $I get the ls command, right? We can hold values, we can hold commands, and the substitution allows us to combine those. But let's look at a more practical example. So in this case, here's what I want to do. I want to send a packet out on the network, and I'm going to use the ping command. And I want to actually see what I can do with that ping command. And I'm going to look at my quick help menu for pings. There's a couple things that I want to do. I want to send a number of packets out, and then I want to actually pad my packets with a certain value. I did this as an example for my networking students, but I'm going to do it a little bit of a different way. In this case, we're going to use command substitution to define what is our stuffing pattern for our packet. So I'm just going to give you a quick example. If I were to ping a host, and I'm going to ping it with 2 packets, I'm going to use the P. Whatever I use for my parameter for P, in this case, I'm going to use E. And then I'm going to use the destination of my local host. Now what should happen in this case is I'm going to create 2 packets, and I'm going to put those packets, I'm going to fill them with the letters EE in the data side. Okay, there's my 2 packets. Now I'm running Wireshark over here. Notice that this is my first packet, and what do I have in my payload section? E. Okay. So if I look at my ICMP packet, my data is actually shoved with some E's. Okay. There's a couple of other things in there as well, but we filled it with E's. And we did it twice. So just to show you that that command is actually working. Now, I could do something else, but let's say I wanted to fill it with the word this. Notice that it gives me an error. I have to specify whatever my payloads are going to be with hexadecimal digits. So I don't really know right off the top of my head. I could convert this. But I'm going to use this hex converter. It's a command called xxd. And we're just going to look at this apropos xxd. It makes a hex dump, or it does the reverse. So how would I use that? If I type in xxd, I just get, I don't know, nothing. Well, what I'm going to do is I'm actually going to send it I'm going to use the echo command. And I'm going to send hello to xxd. So the output of my echo command, which should be the text hello, becomes the input of my xxd command. And what do you know? I get some hexadecimal values followed by a period in this case. All right, hello dot. Now, a little bit of help for my xxd command tells me that if I use the PS switch, I can output in PostScript or plain. And I'm going to go ahead and do that. I'm going to do the P. It's actually P, PS, or plain. It all does the same thing. Notice that what I got right there was only the data. I didn't get the line numbers or the binary or anything or the text. I just got the numbers. So this would be a perfect example for a command substitution or even a variable substitution. I'm going to do it both ways. If I do a ping command and I want to pad the packet with whatever that binary value was. Now notice the last time I did it, it said you can't do that. We need the hex values. So I'm just going to take that out and I'm going to put in my inline substitution. And I'm going to send this information to xxd-p, and I'm going to close my inline substitution. My packets went through. Notice that they are padded with the word hello, 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 hello. How did that happen? This command, echo hello, sent the output to xxd, which was immediately substituted right there on that line. Now I'm going to do something a little bit different. I'm going to go ahead and set a variable I equals. I'm going to do my substitution. Echo sensitive data here. I'm going to pipe it to xxd-p and press enter. Now notice I didn't get any output, and I'm not expecting any, because what I've done is I've assigned this command to an inline substitution variable that is used by a placeholder that's I. Okay. So I can go in here and I can put $I. This is my variable. Now, what happened? I get a ping request. Sensitive data H. Sensitive data H. It didn't finish out the command. I wrote sensitive data here. The reason why I didn't finish it out is because the parameter for ping to pad the packet only allows for a certain number of bytes. In this case, 16 of them. If I can find it. You may specify up to 16 pad bytes. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It got me to H. And there we go. It cut it off. So it took the first 16 and it repeated it over and over and over. It did exactly what I told it to do. I used command substitution. I used a variable, I. I used a ping with switches. I used the padding switch. I used inline substitution to put that variable there. As soon as the command processor saw that, it evaluated what was in I. Remember, echo $I. What am I doing here? This is my actual output from $I. Now that placed it right there where it needs to go in the middle of that command. Fortunately, I don't have any way to not interpret the command. If I needed to see exactly what it was, that would be a problem. Here's one other trick that I can use if I wanted to see what was inside that I. Remember, if I echo $I, I get the actual value. But if I use an exclamation point, I can see the actual value of the variable. So I could go in and actually modify it. It tells me, interestingly enough, it tells me the actual value of the variable, and it tells me the evaluated data that's in the variable is that exclamation point. So just to give you a little tour of some tricks that you can use. Now, when we start combining all these tricks together, you can get some real powerful stuff, and you see how literal it is. So utilize these tricks. Try and find some ways to evaluate some data and place them on the command line. Imagination is a powerful tool.